if we have units that are raised to a power, we have to remember that that is the length, or that dimension cubed. So if we wanted to convert cubic inches to cubic centimeters, our conversion factor is 1 inch equals 2.54 centimeters, but because the unit is cubed, we have to cube the entire conversion factor. Now what I tend to do so that I don't make a mistake is I tend to write the conversion factor 3 times in our dimensional analysis. That way I make sure that everything cancels and I don't make a mistake. I'll show you what I mean in the next example. All right, so let's try to convert 5.70 liters into cubic inches. So for our conceptual plan, we'd start with liters. We go to milliliters, and then remember we have a conversion that allows us to go from milliliters to cubic centimeters. And then finally, we can go to cubic inches. So 1 liter is 1,000 milliliters. This comes from that milli prefix. Milliliters 1,000 times smaller, so it takes 1,000 of them to make a liter. We know 1 milliliter is equal to 1 cubic inch, or 1 cubic centimeter, I'm sorry. And then 1 centimeter, it's not cubic, it's just centimeter, sorry, 2.54 centimeters is equal to 1 inch. So now we can put that into our dimensional analysis. We're going to start with 5.7 liters. We want the liters to cancel, so we're going to put the 1 liter on the bottom, 1,000 milliliters on top. We want the milliliter cancel, so we're going to put that on the bottom, 1 cubic centimeter on top. And now we want, because it's cubic, we're going to have to use 3 of these conversion factors, the centimeters to inches, in order to cancel that cubic unit. So 2.54 centimeters is 1 inch, and that will cancel 1 of the centimeters. So I have to write it again. 1 inch, 2.54 centimeters. That'll cancel the second. 1 inch, 2.54 centimeters. That one finally cancels the centimeter completely. So if we do our math, we find that the answer is 3.47, sorry, let's try that again. 347.835 cubic inches. So how would we round this? Well, again, these conversion factors are all exact, so we would have to look at the number that we started with. So we would have 348 cubic inches. Our units are correct. We're in cubic inches, which is what we wanted. And our number makes sense. So we would have 348 cubic inches for 5.7 liters. Now, why would this matter? You might think about engine sizes. So if you have a 5.7 liter engine in your vehicle, that means you have 348 cubic inches of displacement. Here's one for you to practice. Pause the video. See if you can convert cubic 2.11 cubic yards to cubic centimeters. Okay, so our plan, and you might have a slightly different plan, which is perfectly fine. We can go from cubic yards to cubic inches, from cubic inches to cubic centimeters. You know that 1 yard is equal to 36 inches, and 1 inch, 2.54 centimeters. So let's start our problem. Our 2.11 cubic yards. Now again, this is cubic, so we have to use that conversion factor 3 times so that we can cancel all of them. Want the yards on the bottom so that they cancel. Well, now we're in inches, but we want to get to centimeters, so we have to use our inch to centimeter conversion 3 times. So 1 inch, 2.54 centimeters. That'll cancel one of our inches. And we write it a third time. And that cancels the third inch. Now when we do our problem solving, we would multiply across the top, divide by anything that is on the bottom. We would get 160, or sorry, 161,3210.75 cubic centimeters. Now, does a big answer make sense? Well, a centimeter is much smaller than a yard, so that does make sense. So let's round our answer now to the proper significant figures. We have 3 significant figures in our 2.11 yards, so we can have 3 significant figures in our answer. And sometimes when numbers are very large or very small, it's much easier to look at them in scientific notation. So instead of 1.61 million, we can put 1.61 times 10 to the 6. So our units are correct. We're in cubic centimeters, and we got a much larger number than yards because centimeters are smaller. Now there's some things that are conversion factors in themselves. So density relates mass to volume, and so we can use it as a conversion factor to convert from between mass and volume. So water has a density that is approximately 1 milliliter is equal to 1 gram. Our density is about 1 gram per milliliter for water. Lead is significantly more dense, and so that means that it's 11.3 grams for 1 cubic centimeter of lead. So if we wanted to calculate how much 4 cubic centimeters of lead weighs, we would start with the 4 cubic centimeters. We want the centimeters to cancel, so we would put the centimeters on the bottom, the grams of lead on top, and then we could multiply across the top, divide by anything on the bottom to find the mass of our lead, canceling our units we're left with just grams. Now you can use the density equation. So density equals mass divided by volume. We're trying to figure out how many grams. So we would have to take our density times volume equals mass. Well, that's exactly what we did with our dimensional analysis. So here is our volume, and here is our density. We multiplied the volume by the density to get the mass. We just used the units to help us decide that instead of having to figure it out ourselves. So here's an example. So what is the mass in kilograms of 173,231 liters of jet fuel? And we're given the density. So we're trying to find mass. We're given 173,231 liters. We're also given the density. So why would we have to find the mass of jet fuel? Well, planes can only take off with a certain amount of weight. So the amount of fuel that they're carrying is an important thing to know. So for our conceptual plan, we're going to go from liters to milliliters to grams. And because grams are pretty small, we might want to report this in kilograms, and we're asked to report it in kilograms. So we know that 1 liter is 1,000 milliliters. We can use the density to get from grams to milliliters, or milliliters to grams. And then there's 1,000 grams in 1 kilogram. So grams are smaller. It takes more of them to make 1 kilogram. Now we can put this into our dimensional analysis. Want our liters to cancel, so we'll put 1,000 milliliters on top. We can use our density. To get from milliliters to grams. And then we know there's 1,000 grams in 1 kilogram. So now when we do our math, we would multiply by the numbers on top, and we would have to divide by 1,000 because there's 1,000 grams on the bottom. This results in mass of 1.33041 times 10 to the 5th kilograms. How about our significant figures when we're rounding? Well, normally we look at our first value. Here we have 6. We know that the milliliters and liters is an exact conversion, the grams and kilograms is, but our density is a measured value. That's something that is determined. So this only has 3 significant figures. Because it's a measured value, that means we have to round our answer to 3 significant figures. So our units make sense. We're in kilograms. We would expect a very large value because our volume is very large. And so this makes sense as an answer. Here's one for you to try. What volume does 100 grams of marble occupy? The density is 4 grams per cubic centimeter. Pause the video and try to solve this problem. Well, we have 100 grams of marble. We want the grams to cancel, So we're going to put the number that is associated with the grams on the bottom, 1 cubic centimeter on top. The grams cancel. We have 4 significant figure, or well, 25 cubic centimeters, 4 significant figures from the grams, 2 for our density. So we would report our significant figures to 2 for our answer. The units are correct for a volume, and the density or the volume makes sense because our density is larger than 1. We would expect a number smaller than 100.